Right, grade 12s. Let's have a look at another example that involves determining the coordinates of the center and finding the radius of given circles. Now, what I want you to do in these particular examples that are going to follow, I want you to determine the coordinates. Okay, there's the important word, the coordinates of the center and the radius for each circle that follows. Okay, for each of the following circles, for each circle that follows. So you want to get the coordinates of the center and the radius of the following circles. Now let's have a look at the first one, number A. If I said to you x squared plus y squared is 9, what are the coordinates of the center? No problem. Remember, it's always got to be in a form that we can determine. And I think this is going to be the origin. The form that we can determine is x minus 0 squared plus y minus 0 squared is 9. And you'll notice that, what do you notice about the center here? It is 0, 0. That is the center. The coordinates of the center would be the origin. Okay. In other words, the circle is going to pass through the origin there. Its center lies on the origin, 0, 0. And the only thing left to do is to get the radius. Now, the radius of the circle, if you think about it, r squared is 9. So the radius is the positive square root of 9. We're not going to go plus minus here. The radius of a circle is always positive. Okay, now let's have a look at another one where it's not at the origin. What if you get a circle like this? It looks something like this. X minus 2 squared plus y plus 1 squared is equal to 10. Now you want to get the coordinates of the center. Now the trick with this, remember, you could have done this. You could have said x minus something plus y minus the negative 1 squared. But that's actually quite complicated there. So I'm going to show you a shortcut to get the center. What we do is we take that, it says negative 2, and inside it becomes 2 there. This is plus 1 becomes negative 1 there. So the center is from negative 2 goes to 2 and then negative 1. And you can see it's clearly, that would be, if you look at it, x minus a, y minus b there. You see, but I like looking at this and saying, well, if it's minus 2, it's 2 there. If plus 1, it's going to be minus 1 in the center, the coordinates of the center there. Okay, and what about the radius? Well, the r squared is 10. So the radius is a third, the square root of 10 units. Okay, that is the radius of the circle. Okay, now remember what we did in the previous lesson. What if you have it in a form when we multiplied out? So you had something like this. X squared plus y squared minus 6x plus 4y minus 4 is equal to 0. And you have to determine the coordinates of the center and the radius of this circle. But this is really one of these previous circles. If you have a look at this, it's like this guy that's been multiplied out. In other words, what you would have done is you would have said x squared minus 4x plus 4, and it's multiplied out. And now we've got to get it into this form to be able to determine the center. Now, it involves something that you did in previous lessons or in grade 11. It's called completing the square, and I'm going to show you exactly how to do that. Good, let's have a look at that. Okay, now people, I'm going to do this very slowly. Okay, it's not difficult, but many students battle with this. I'm going to put the x squared term, the x squared and the negative 6x together, and then I'm going to group the y terms, so it's y squared plus 4y. Let's put them together, and I'm going to bring that negative 4 to the right. Now, what we need to do is we need to complete the square. Now, I want you to watch this very carefully. People, what actually happens here, I want you to focus on, let's look at x squared minus 6x. Now, when you complete the square, what happens is you add this half the coefficient of x all squared to that. That makes it, remember in grade 11 they say what must be added to this expression to make it a perfect square trinomial. So what you do now, watch this carefully, we got x squared minus 6x plus a half of negative 6 all squared, which is really, if you think about it, this is going to give you x squared minus 6x plus a half of negative 6 is negative 3 squared, and that would give you then 9. Now the beauty of that is it's going to be x minus 3, which is x minus 3 squared. This is a perfect square trinomial. Now likewise, what we're going to do is we're going to take this, I'm just going to bring him down here. Let's move that up, the y squared plus 4y. Let's see what happens here. Y squared plus 4y. Well, what must we add to this to make it a perfect square? It's a half the coefficients of y all squared. So this gives us y squared plus 4y. A half of 4 is 2, and 2 squared is 4. And you probably remember that this is going to be y plus 2y plus 2, which of course is going to give you y plus 2 squared. Now this is important because these guys will help us get the center. So if you focus on this thing, what did we do originally? We've got to add half the coefficients of x all squared, and we add half the coefficients of y all squared. But you can't just add these in to this equation and not add it on the right. That's a fundamental principle of maths. If you remember from grade 7 and 8, if you add something in to the left, you must do it on the right. So what we then do is we do the following here, and I'm going to rewrite that equation quickly. Have a look at this. If you've got x squared minus 6x plus y squared plus 4y is equal to 4. What we did is, remember, we worked out half the coefficient of x, which was, if you think about it here, we were adding in fact, this guy here, which is 9. So we added in 9, okay, there. And then to this y squared plus 4y plus 4, we added in 4, if you remember. Over here, we added in this little 4. And you see it, half the coefficients of y squared. So we added in the 4, and we added in the 9. Okay. Now, what you do is, if you look at the right side, I'm just going to go to the bottom here. That 4 is over here now. But remember, you added a 9 and a 4 to the left. So you must add a 9 and a 4 to the right as well. Okay, that's important. Now, when you've done this factorized as x minus 3, and this factorized, this guy factorized as y plus 2, which is y plus 2 squared. So this gives you 17. 9 plus the 8 is 17. Okay, now look how easy this is, because if we want the center, we can then say that is going to be, what's that? Negative 3 becomes 3, and positive 2 becomes negative 2, and the radius is the square root of 17. So what you're really doing with this is you're adding in, that there is half the coefficients of minus 6 all squared, and what you added in here is going to be, if you look at that, it's half the coefficient of y, which is a half of 4 all squared, which is 4. But you also added, so if you've put it there, it must go on the right. If you put that one there, it must go on the right there. Okay, and then that 4 just comes down here.